Hello students, now today we are going to discuss manipulation of discrete time signals. In digital signal processing, already I told you as far as signal is concerned, how the discrete time signals can be performed in addition, subtraction and also shifting, we can say maybe delay or maybe advance. So as far as manipulation of discrete time signals, if there are number of discrete time signals are given, means x1 of n, x2 of n, x3 of n, if you will add it, that means x1 of n with add with x2 of n with x3 of n, what will be your sum of the signals x1 of n, x2 of n and x3 of n. So now in manipulation of discrete time signals, suppose the addition operation, in case of addition operation, in case of addition operation, suppose let two discrete time signals are given, one is your x1 of n, let this is your x1 of n, if you will add with another discrete signals like x2 of n, and if you will add two discrete signals x1 of n and x2 of n, and let y equal to your x1 of n plus x2 of n. For example, if I will say in case of let x1 of n equal to your, that is your 1, that is your 0, 3, is your, the discrete signal x1 of n can be represented in sequence representation like this. This arrow mark indicate, already I told you, for n equal to 0, for n equal to 0, x1 of 0 2, for n equal to 1, x1 of 1 equal to 0, for n equal to 2, x1 of 2, that is 3. This is nothing but a sequence representation. So already I told you how you represent the discrete signal in the form of either you can represent sequence representation, can be tabular representation, can be graphical representation. As far as graphical representation is concerned, if you will represent graphically, suppose at n equal to 0, this arrow mark indicate for n equal to 0, that is your x1 of 0, that is your 2, x1 of 0, that is your 2. Similarly, for x1 of n equal to 1, that is your 0, this is 1, there is no, the signal is absent. For n equal to 2, that is 3, for n equal to 2, that is your 3. N equal to 2, that is your x1 of 2, that is your 3. Similarly, left side, this is your n equal to minus 1, for n equal to minus 1, x1 of minus 1, that is 1. For n equal to minus 1, x1 of minus 1, that is 1, this is your minus 1, this is 1. This is your graphical representation of discrete signal x1 of n. Similarly, if you will another signal let x2 of n equal to, if I will say that is your 0, 1, 2, here, that is your minus 2 and 3, this is your x2 of n. And in sequence representation, discrete signal x2 of n can be represented like this. As far as graphical representation is concerned, similarly here for n equal to 0, this arrow mark indicate for n equal to 0, for n equal to 0, x2 of 0, for n equal to 0, x2 of 0, that is 2, x2 of 0, that is your 2. Similarly, for n equal to 1, x2 of 1 equal to minus 2, for n equal to 1, that is your minus 2, this is your minus 2. Similarly, for n equal to 2, that is 3, for n equal to 2, that is your 3, this is your n equal to 1, n equal to 2, that is your 3. Similarly, left side of the arrow, for n equal to minus 1, n equal to minus 1, that is 1, this is minus 1, for n equal to minus 1, that is your 1, and n equal to minus 2, also that is your 0. This is your representation of discrete signal, this is your n, and this is nothing but your what? x2 of n. So either you can represent sequence representation is given, or maybe graphical representation given. So if you add two discrete signals, means x1 of n with x2 of n, this with this, what will be your result? So first of all, you must add for n equal to 0, for n equal to 0, x2 of 0, that is 2, for n equal to 0, x1 of 0, that is 2, 2 plus 2, that is your 4, so that is your 4. For n equal to 0, the resulting addition operation of two discrete signals for n equal to 0, here n equal to 2, n equal to 0 that is 2, for n equal to 0 2, 2 plus 2 4. Right side of the arrow mark that is your n equal to 1 that is 0, here that is your minus 2. So 0 minus 2 that is nothing but your minus 2 similarly. Similarly for n equal to 2, 3, n equal to 2 that is your also 3, 3 plus 3 that is your 6. Similarly for n equal to minus 1, 1, n equal to 1 minus 1 also 1, 1 plus 1 that is your 2. Similarly 0 and there is no signal present at n equal to minus 2, that's why 0. So 0 plus 0 that is your 0 like this. This is nothing but your y equal to x1 of n plus x2 of n. When addition operation is performed are going to perform, simply you will add each values of n, you will add amplitude, you must be add for x1 of n with x2 of n. But you have to mark where is your origin. Here origin n equal to 0, this arrow mark indicate n equal to 0, here 2, here n equal to 0 that is 2. Similarly you just add like this. Suppose if I will say another discrete signal x3 of n will add, that is your result will be what? x1 of n plus x2 of n plus x3 of n. So then you have to look whether n equal to 0 for x1 of n, n equal to 0 for x2 of n. If another discrete signal is given for n equal to 0, x3 of n, then you will add all these values and resulting for n equal to 0, you will add x1 of 0 plus x2 of 0 plus x3 of 0. This arrow mark indicate for x1 of 0 plus x2 of 0. This arrow mark indicate for n equal to 1, x1 of 1 plus x2 of 1. This value is indicate what? That is this 0, 1, 2. That is your n equal to 2. That is your what? x1 of 2 plus with x2 of 2. And left side of the origin, that is your minus 1, n equal to minus 1, and this indicate what? x1 of minus 1 plus x2 of minus 1. In this way, the addition operation can be performed. This is what in manipulation, as far as manipulation of discrete signal is concerned, we can add different discrete signals like this. Similarly, if you will say, if you will subtract the two discrete signals, means if I will say x1 of n, subtraction operation. In subtraction operation, exactly same thing. If you will say, suppose x1 of n minus x2 of n, y equal to y of n equal to what? That is your x1 of n minus x2 of n. This minus this, exactly same thing. Subtraction operation, that means what? What will be? What will do? For n equal to 0 that is 2, for n equal to 0 2. This minus this. So 2 minus 2 that is your what? 0. That means your origin for n equal to 0, x1 of 0 minus x2 of 0 that is 0. For n equal to 1, 0. For n equal to 1 that is your minus 2. So this minus this 0 minus of minus 2 that is your plus 2, that is plus 2. Similarly, this is your 3 and this is your 3. 3 minus 3 0, this is your 0. Similarly, this is your n equal to minus 1 1 1 minus 1 0 like this. This is nothing but what? That is your y of n equal to x1 of n minus x2 of n. Either addition or subtraction operation can be carried out. You have to look for n equal to 0 1 2 3 for different signals x1 of n, x2 of n, x3 of n like this. In this way, the addition and subtraction operation can be carried out. Next, this is nothing but your addition and subtraction operation, and most important thing is your what? That is your delay. What do you mean by delay? As far as discrete signal is concerned, suppose x of n is your discrete signals. If x of n is discrete signals, if it is delayed by k units of time, and the resulting signal is nothing but x of n minus k. Remember, if x of n is your discrete signals, if it is delayed by k units of sample, and the resulting signal is your x of k n minus k. Here k is a positive integer. Here k is a positive integer. Here k is a positive integer. What does it mean? Suppose, for example, if I will say x of n equal to your, as far as graphical representation is concerned, that is your here 2, and for n equal to 1 1, and like this is your 3, and let this is your 1 and like this. So this is your 0, 1, 2, this is your -1 and -2 also I can say that is your 2. This is your -2. So this is nothing but your n and this is your x of n. As far as graphical representation of discrete signal is concerned, this is the signal is given x of n. You may express in a sequence representation like this. For n equal to 0, that is your 2. For n equal to 0, 2. For n equal to 1, that is 1. This is your 1. N equal to 3, this is your 3. N equal to -1, that is 1. N equal to -2, that is your 2. This is your sequence representation of discrete signal like this. Either you may express the discrete signal x of n by means of graphical representation, by means of sequence representation. The question is, if original signal is x of n and if you delayed by k unit of samples, what will be your resulting signals? After delay, here k is a positive integer. The resulting signal is nothing but x of n minus k. For example, if I will say, if x of n is given, you have to determine x of n minus k. Find x of n minus 2. Find x of n minus 2. What does it mean? Here k is your positive 2, but this is your x of n. So if it is delayed by 2 units of samples, the original signal, if it is delayed by 2 units of samples, what will be your resulting delayed signal? That means what? If it is delayed by 2 units of sample, each amplitude of each signals will be shifted towards right by 2 units of samples. For example, here for n equal to -2, whatever the value of n equal to -2, that same value will be appear 1, 2, here 0. What will be at n equal to -1, that means 1, it will appear at +1. What will be at n equal to 0, that will be appears at the 2. That means it will shifted towards right. If it is delayed by 2 units of samples, each signals can be shifted towards right by 2 units of samples. That means here your original signal is what? X of n. This is your 0, 1, this is your 2, 3 and this is your 4. Like this. If I will say x of n minus 2, whatever at n equal to -2 by 2 units of sample, it will shifted towards right by 2 units of sample exist at 0. That means here this is your 2. Here 2. Similarly, this is your 1. If you mark here, each samples that will shifted towards right by 2 units. Here k is positive, here k is your 2. If it is delayed by 2 units of sample, I can say this is nothing but your x of n minus 2, x of n minus 2. Your original signal is your x of n and your delayed signal is your x of n minus 2. In graphically, each samples can be shifted towards right by 2 units. But in case of sequence representation, x of n minus 2, x of n minus 2 is how much here? That is your 0, that is your 2, 1, 2, 1, 3. Here origin is like this. Okay. What is the difference between the two signals? This is your original signals and this is your delayed signals. If you delayed by 2 units of samples, in graphically, each sample can be shifted towards right by 2 units. Each sample shifted towards right by 2 units. Here, it can be appears at 0 here, like this. This one, n equal to -1, appears at n equal to 1. And 0 appears at 2. And here, 1 can be shifted to 3. And 2 can be by shifted by 2 units of sample, that is your 4. And if you observe in sequence representation, the arrow mark can be shifted towards the left by 2 units here like this at 2. Remember. If x of n in graphically each samples can be shifted towards the right, but in case of sequence representation arrow mark can be shifted towards the left by 2 units. The important thing is what? As far as shifting is concerned, if it is delayed in graphical representation, each samples can be shifted toward the right by 2 units, and but in case of sequence representation, the arrow mark shifted toward the left by 2 units. Okay, in graphical representation, each samples can be shifted toward the right by 2 units, but in case of sequence representation, the arrow mark can be shifted toward the left by 2 units here. So this is all about your what? Delayed. If I'll say the advance, what is advance? If I'll say advance, what is advance? As far as shifting is concerned, one is your delay, another one is your advance. If it is delayed, here k is positive. If it is advance, if x of n is your discrete signals, if it is advanced by k units of samples, if it is advanced by k units of samples, and the resulting signal is nothing but x of n minus of minus k, and that is your what? X of n plus k. Here k is a negative integer. Here k is a negative integer. Here k is a negative integer. As far as shifting is concerned, it is very, very important. The student might have maybe put wrong slightly. If you do the slightly mistake, delay and advance, your entire calculation will be wrong when you will perform convolution, correlation like this. So shifting is very, very important. Since it is a very, very easy, and you have to look whether it is delay, whether it is advance. If it is a delay means in graphically the each units of sample shifted toward right, but in sequence the arrow mark shifted to the left, but in case of advance it is opposite. Here k is a negative integer. What does it mean? Exactly same thing whatever we have proceeded in the delayed, it is opposite in case of in advance. The same example, if I will say x of n is your like this, if I will say x of n plus 2, here k is a negative integer, the time shift results k is a negative integers. If x of n is advanced by k units of samples, the resulting signal is nothing but x of n plus k. If x of n plus k, if I will say that is your x of, another example, suppose if I will say x of n equal to, that is your this is your x of n, we have to find x of n plus 2, x of n plus 2. So here k is a negative integer, means x of n plus 2 is nothing but what? X of n plus 2 is nothing but x of n minus of minus 2. So that is in case of graphical representation here, for n equal to 0, that is your 2, that is your n equal to 1, that is 1, and this is your n equal to 2, that is your 0, n equal to 3, that is your 3, that is your 3, and this is your minus 1, this is your minus 1. This is nothing but your n here, and this is your what? X of n. What we will do? Now we are going to find out x of n plus 2. This is your x of n. For advance x of n plus 2, what is my x of n plus 2? What is x of n plus 2? That is your what? This is nothing but 0, 1, and you can mark it in x-axis here like this. In graphical representation, in case of delay, the each unit of sample, if it is a k is a positive integer x of n minus 2, graphically can be shifted toward the right. But in case of advance, the each samples can be shifted to the left by 2 units of samples. whatever n equal to, this is your -1, that means what? It becomes to the what? Left. So here that is your n equal to 0, n equal to 0, that is 2. Here n equal to 3, that is your 3. So these samples can be shifted to the left by 2 units of sample. You have what? At 1. At n equal 1, at n equal to 1, this is your 3. Then here, this is 1, this is your 2, and this is your -1. This is nothing but x of n plus 2. Each sequence shifted to the left by 2 units of samples. That means what? Whatever 3 at n equal to 3, that is your 3, it will appear at n equal to, by shifted to the left at n equal 1, n equal 1, that is 3. 0 again appears by here 0, that is 0. 1 appears at n equal to -1, like this. And in case of sequence representation, so I can write here x of n plus 2 equal to how much here? Like this. For n equal to 0, that is your 0, that is your 3, like this. This is your x of n plus 2. In case of shifting is concerned, x of n plus 2, what you will mark as far as sequence representation is concerned. In case of sequence representation, the arrow mark shifted by 2 units of samples, 2 units by right, towards right. If it is in advance, in graphical representation, each samples can be shifted toward the left, but arrow mark shifted toward the right. But in case of delay, the graphical representation, each samples can shifted toward the right, but arrow mark shifted toward the left here. The arrow mark, whatever the arrow mark here, shifted toward the right by 2 units here, like this. This is all about your what? How you shift your discrete signals. In case of discrete time signals, that is your, as far as in manipulation of discrete signal is concerned, here that is your addition operation, addition or subtraction operation can be carried out by what? Simply you will add at respective value of discrete signals for n equal to 0, 1, 2, 3 or -1, -2, -3. Then you will obtain, that is your x1 of n plus x2 of n. How will you get x1 of n, x2 of n? For every successive value of n equal to 0, 1, 2, 3, n equal to 0, 1, 2, 3, you will add this with this, you will add this with this, you will add this with this, you will get this one. Similarly, at n equal to -1 and n equal to -1, if you will add in this way, you will get x1 of n plus x2 of n, like this. Similarly, also subtraction operation, x1 of n minus x2 of n. If you subtraction operation, how will a subtraction operation carried out? In if the discrete signals is given, x1 of n and x2 of n, simply you subtract this minus this. For whatever n equal to 0, whatever this equal to 0, this minus this, 2 minus 2, that is your 0 here, like this. For n equal to 1, n equal to 1, this minus this, 0 minus 2, minus plus 2, like this. In this way, you can perform the addition operations. Then we have discussed, that is your delay. As far as shifting is concerned, shifting of discrete signals. As far as shifting of discrete signal is concerned, one will, that is your delay, very, very important, delay and advance. So you may not confuse when you are going to shifting means maybe delay or maybe advance. If x of n is given, then if it is a delay, if x of n is your original signal, if it is delayed by 2 units of samples or k units of sample, here k is a positive, x of n minus k, here k is a positive integers. If k is positive integers, if x of n is your original signals, then in graphical representation, each units of samples can be shifted toward the right. Remember, in graphical representation of discrete signals, as far as the delay is concerned, each sample can be shifted toward the right. If it is x of n minus 2, if 2, Shifting means each samples can be shifted toward the right by 2 units. Whatever this will appear at 2 units means 1, 2 here. Whatever this by 2 units, 1, 2. Whatever this it will appear to this 1, 2 like this. Like this. This is your x of n minus 2. If you observe in graphical sequence representation, if graphically shifted toward the right, but the arrow mark shifted toward the left by 2 units, then like this one. Here x of n minus 2 is like this. Arrow mark shifted to this one. This is all about your delayed. If it is advanced, if x of n advanced by k units of samples, here k is a negative integer, x of n minus minus of k, x of n plus k. Remember here k is a negative integer. If k is a negative integer, the discrete signal results advanced in nature. So that's why, if for example a original signal x of n is given, so we are going to find out x of n plus 2. Here k is your minus 2. Here k is your minus 2. If it is an advance in a delay, what happened here? Previous case, the graphically shifted to the right. But in case of advance, the graphically shifted towards the left. If graphically shifted to the left, the arrow mark shifted to the right. Here arrow mark shifted to the right here. Whatever this appears at this one. And graphically this shifted to the part, that is your left. Whatever this appears at this n equal 1 like this. This is all about your delay and advance. So now we will discuss next class what is time reversal folding. Then after folding, how will you shifting? Already you know what is x of n. Folding means x of n minus of n. After folding, then shifting x of minus n plus k, x of minus n minus k. So there are different type of discrete signals you will obtain after folding and then shifting like this. So I will stop here today. Then next class we will see more and more number of problems or numericals we will solve. So how will you if a number of discrete signals are given, how the folding, how the delayed and advanced or will perform, that is your convolution or correlation, different type of examples or numericals will be carried out. Thank you.